Hello, this video is on right-angled triangles, specifically on the use of the sine, cosine and tangent ratios and Pythagoras' theorem, as shown here in the syllabus. A right-angled triangle is a triangle that has one of its angles equal to 90 degrees. The side opposite the right angle is called the hypotenuse and is the longest side of the triangle. Pythagoras' theorem states that a squared plus b squared is equal to c squared, where c is the hypotenuse and a and b are the sides that are at 90 degrees to each other. You should already be familiar with using the three trigonometric ratios, sine, cosine and tangent, in right-angled triangles to calculate lengths and angles. You might be familiar with these triangles, which can be used to remember the ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In the right-angled triangle shown, we can use Pythagoras' theorem to calculate the length of AB. Identifying AB, or C, as the hypotenuse, the longest side, opposite the right angle. Squaring and adding the two shorter sides, and then square rooting the result, gives a length of AB equal to 9.43 centimeters, correct to three significant figures. In this example, we can use Pythagoras' theorem in the right-angled triangle shown to calculate the length of BC, one of the shorter sides. Identifying the hypotenuse as the length of 13 centimeters, squaring and adding the two shorter sides and equating that equal to 13 squared, the hypotenuse squared. Subtracting and then square rooting gives a length of BC equal to 11.0 centimeters, correct to three significant figures. Alternatively, you can solve the equation on your calculator. To use solve n from the main menu, select Run Matrix, then press the Option key and an F4 for a calculation, and an F5 for solve n. Typing in the equation using the x variable to represent a, so x squared plus 7 squared, shift to access the equals, 13 squared. Closing the brackets and pressing execute. Pressing exit and pressing the decimal display button. We see that there are two square roots of 120, and again the positive one is 11.0 centimeters. In the right-angled triangle shown in this example, we can use trigonometry to calculate the length of AC. Identifying the hypotenuse as the longest side, the side opposite the right angle. Identifying AC, or B, as the opposite side, as it's opposite the 30-degree angle. Referring to our triangles, sine is the ratio of opposite over hypotenuse. So we write sine of 30 is equal to b over 13. Rearranging the equation to find b, additionally covering up the opposite in the triangle, we see that we need to multiply the sine of the angle by the hypotenuse. So multiplying the sine of 30 by 13, we see that AC is equal to 6.5. Alternatively, we can use solver on the calculator. So from the main menu, we select equation and press F3 for solver. There's no need to rearrange the equation, we can just type it in as it is. And we can just type over any previous equation. So pressing Sine and 30 and Shift to access the equal sign, and then a fraction button, and put in the X variable on the top to represent B, the down cursor, and then 13 in the denominator. Pressing Execute to enter the equation. And just to note that the number next to X is not the solution to the equation, as we haven't pressed Solve yet. Pressing F6 to solve the equation, we see that X, or AC, is equal to 6.5 centimeters. In the right-angled triangle shown in this example, we can use trigonometry to calculate the length of AB. Identifying AB as the hypotenuse, the longest side, it's opposite the right angle. Then identifying 8 centimeters as the adjacent side, as it's next to the 30-degree angle. Referring to the triangles, see that cosine is adjacent over hypotenuse. So we write that cosine 30 is equal to 8 over c. Rearranging the equation to find c. Additionally, in our triangle, if we cover up the hypotenuse, we see that we need to divide the adjacent by the cosine of the angle. Alternatively, we don't need to do any rearranging, we can just type the equation as it is into equation solver. So in the calculator, if I press F1 for a repeat calculation and scroll up, I can then type the equation. So that's cosine of 30 degrees, Shift to access the equals, and then the fraction, and 8 in numerator, and the down cursor, and put in the X variable to represent C. Pressing Execute to enter the equation, and F6 to solve the equation. So AB is equal to 9.24 centimeters, correct to 3 significant figures. In the right-angled triangle shown in this example, we can use trigonometry to calculate the size of angle ABC. That's angle B. And I'm using the Greek letter theta to represent the angle. Identifying 5 centimeters as the side opposite the angle theta, and 8 centimeters as the side adjacent to the angle theta. Referring to the triangles, we see that tangent is equal to opposite over adjacent. So we write tan theta equals 5 over 8. We can either calculate theta by using solver. So on the calculator, if I press F1 for a repeat calculation and scroll up and type in the original equation. So tan, and then press X to represent the angle, Shift to access equals, and then the fraction, and 5 in the numerator, and scroll down, 8 in the denominator. Pressing Execute to enter the equation, and F6 to solve the equation. Alternatively, we can use the inverse trigonometric functions. And tan to the minus 1 is called inverse tan. And to do this, from the main menu, if I select Run Matrix and type in the calculation, pressing Shift to access inverse tan, and then put in a bracket and a fraction, and again 5 in the numerator, and scroll down, put in 8 in the denominator, and scrolling back up and closing the bracket and pressing execute to perform the calculation. So angle ABC is equal to 32.0 degrees, correct to 3 significant figures.